In this lecture, we take another very important topic, vectors and scalars. Let me remind you that you must understand the distinction between vectors and scalars very clearly, and you must also understand how to deal with vectors, because in your class 11 and 12 you will be required to write all formulae in terms of vectors. And once you understand vectors, let me assure you, you can understand the phenomena being taught to you much better than you can understand with scalars. To give you an example of a scalar, suppose the teacher is asking each student to stand up and state his or her height. Each student speaks out a number, say 160 centimeters, 165 centimeters, 155 centimeters, and so on. You do not have to add anything more to the number that you speak along with the unit of course to state your height. Take another example. You say the mass of a ball is 50 grams. We do not have to add anything more to the description of the mass. So, in physics we come across two kinds of quantities. One kind is such that we need not state anything else except the magnitude expressed in proper units. The examples are, as I said earlier, height and mass. Another example is the density of water. You state that it is 1000 kilogram per meter cube. You do not have to add anything to refine your statement. Statement 1000 kilogram per meter cube is a complete description of density. You do not have to say anything in which direction and so on. So, quantities like mass and density are called scalars. A scalar quantity has only magnitude, it has no direction. On the other hand, there are quantities which require both magnitude and direction for their complete description. A simple example is velocity. The statement that the velocity of a train is 100 kilometers per hour does not make much sense unless we say the direction in which the train is moving. Vector is a word borrowed from English language. In the dictionary meaning of vector is something that moves. If you are a student of biology, you would recall that mosquito is said to be the vector of malaria, because mosquito moves from one person to another carrying the microorganism which causes malaria. Therefore, the vector is something that moves, and we have borrowed that word and in physics, and we say a quantity is a vector if it requires both magnitude and direction for its complete description. Force is another quantity. To say that the force acting on a body is 10 newtons does not make sense. We must also state the direction in which the force is acting. Thus, to say that the force acting on a body has magnitude 10 Newton and it is acting vertically downwards gives a complete description of the force. So, to sum up, a vector quantity has both magnitude and direction. Some examples of vector quantities which you come across in mechanics are displacement. You know, if you move from one point to the other irrespective of the path, if I take the difference between the position B and position A, that is called displacement. If I take account of the path taken between point A and point B and measure this length, that is the length of the path. The displacement is simply the difference of positions from position B minus position A. Displacement is a vector, as we shall see later on also. Velocity, we have to give the direction in which the body is moving, and therefore, velocity is a vector. Acceleration, whether the acceleration due to gravity is vertically downwards, we have to give the direction. That is why g the acceleration due to gravity is also a vector. Momentum again requires direction, and therefore, along with the magnitude, and therefore, it is a vector. Angular momentum, torque, all these are vectors. And area, I have chosen this area because many times area you would deal with area as vector. So, let us see what is this vector. Area vector is a special type of vector. Its magnitude is the area of the surface itself, and the direction is the normal to the surface. In this diagram, the surface area is the magnitude and the normal to the surface is the direction of this vector. Another vector which is slightly peculiar is angular velocity vector. The magnitude of the angular velocity vector is the rate at which something rotates, or the magnitude of the angular velocity, and its direction is along the axis about which it rotates. So, it is a special kind of vector, but it is a vector all the same. What about energy? Is it a scalar or a vector? To get the answer, think if there is a direction associated with, say, magnetic energy or nuclear energy. If no direction is associated, then it is a scalar. Other examples of scalars are mass, distance covered, speed, work done, and pressure. Pressure is particularly important because there is a confusion always, because pressure is force per unit area, and force is a vector. Therefore, pressure sometimes students confuse whether it is a vector or a scalar, but remember, force is divided by area, and area I have told you earlier is a vector. Therefore, F by A both being vectors, the result is a scalar. So, pressure is a scalar. How do you represent a vector? The vector is represented by a line with an arrow on one side. The arrow indicates its direction and the length of the line indicates its magnitude. You can see that this A is blinking. So, just to make sure, this A is called the tail of the vector and B is called the head or the tip of the vector. B is the point where the arrow points. Therefore, B is called the tip or the head of the vector. Here I have drawn three vectors. Two of them, vector AB and vector CD, they are parallel, but they have different magnitudes. Vector EF has same magnitude as the vector AB, because the length of the line is the same, you can check, but its direction is different. So, all these vectors have different properties. CD and AB are parallel, but have different magnitudes. EF and AB have the same magnitude, but different directions. Two vectors are said to be equal if their magnitudes are equal and they point in the same direction. It is not necessary that they be in the same line. You can see from the example here that vector A and B are in the same line and they have the same magnitude, therefore, they are equal. On the other hand, vector C and D, they are also parallel, that means they are in the same direction and their magnitudes again are equal, and therefore, vector C is equal to vector D. You see, please remember this equality thing. Many times you will find vectors, one vector is here, the another vector is somewhere else. But remember, as long as the magnitude of the vectors is the same and they point in the same direction, they are equal. They may not be in the same line. All that we need to understand is vectors are equal when their magnitude is equal and they point in the same direction. Here I have drawn three vectors A, B and C. They are all equal, you can see why. They are all parallel and they are pointing in the same direction. Their arrows are in the same direction. If I have two vectors whose magnitudes are equal, but they point in opposite direction, they are called anti-parallel vectors. Here they are parallel vectors, they all point in the same direction. But if two vectors point in the opposite direction and their magnitudes are equal, then their equal and opposite vectors. All vectors here which I have shown, they are unequal. Why are they unequal? Let us remember the definition of an equal vector. Two vectors are said to be equal if they point in the same direction and are equal in magnitude. Here vectors g and h, they have the same magnitude, but they are pointing in different directions, and therefore, by our definition they are not equal. Vectors e and f, they point in the same direction, but they have different magnitudes. Therefore, again by our definition they are not equal vectors. Equal vectors, let me emphasize, are those vectors which point in the same direction and which have the same magnitude. In the next lecture, we shall deal with the operations on vectors. Let me add a few points to the discussion of these vectors and scalars. One thing that extremely important for students of physics to understand vectors and their operations. Operations we shall do later on. But to understand what a vector is, what it represents, what it stands for is important. You also must remember that two vectors can be equal even if they are not along the same line. All that is required is that they must be parallel and their magnitudes must be the same. Another thing, in many books you would find vectors written as with arrow on top of them. For example, vector A would be A, on top of which would be an arrow. In many books, on the other hand, adopt a different convention. In those books, the vectors are represented by bold letters and scalars by normal letters. For example, if I have to show that A is a vector, then A would be bold and the magnitude of A, the magnitude will be a normal and the vector itself would be A in the bold font. So, this is how we represent vectors. And another important thing, we have done a dimensional analysis. We have seen that dimensions of an equation, of all terms of an equation on the two sides must be the same. Add it to another thing. If one side of an equation is a vector, the other side of the equation must also be a vector. If there are three terms on the right hand side, they must all be vectors, and the term on the left hand side should also be a vector. So, if you write an equation in which the left hand side is a vector and the right hand side is not a vector, then the equation is wrong. For example, you may write the force between two masses, gravitational force. You write G times m1 m2 by r squared, and recalling that force is a vector, you say F vector is equal to m1 m2 by r squared into G. That would be wrong, because the right hand side you have made a scalar and the left hand side you have made a vector. How we can make the right hand side also a vector is by introducing what are known as unit vectors, which we shall see later. But remember that both the sides of an equation and all the terms in an equation must be vectors. If they are not, then you have a problem, then the equation would be judged as wrong. So, while on this topic, important to understand the concept of vectors, and also we shall see next time how vectors can be added, how they can be multiplied, how they can be resolved and synthesized, and how the unit vectors help us in putting the equation, for example, the gravitational force correctly, so that both the sides are vectors.